Hello everyone, welcome to another video. Today we will learn about creational design patterns. Before we move on to creational design patterns, let us understand what are design patterns and why we need them. Design patterns are proven, reusable solutions to common software problems in software design. They act as templates, blueprints for structuring out the code, classes, and interaction between them, so that we are able to build extensible, maintainable, and scalable software architecture. On a high level, there are three different types of design patterns. First, creational design pattern. It deals with how we create an instance of a class. Second is structural pattern. Deals with how classes and objects are combined to form a larger and more complex structure for efficient use. And third is behavioral pattern, which deals with how classes and objects communicate with each other. Starting with creational design pattern, there are 5 types of creational pattern. First is singleton, builder, prototype, factory, and the last one is abstract factory. Starting with singleton pattern, when we want to ensure that only one instance of a class should be created, we use singleton pattern. To use this pattern, we define a private static member variable of class. We use static here because static variables are shared across class objects. We will define a function getInstance that will return existing instance of the class, or will create a new instance if it does not exist. This function will also be static. Finally, the last step is to make the constructor of the class as private so that the class object cannot be created from outside of the class. This is how we implement the singleton pattern. To create an object of the class, we simply call getInstance method from the class, as we have shown here. The next is builder pattern. Imagine you have a class with many member variables defined in it. Some fields are optional while some are mandatory. If a client has to initialize different objects with different set of fields, we will need to provide with multiple constructors with different combination of fields. That's a lot of duplicate work. To overcome that, we use builder pattern. We define a nested class product builder containing the same set of fields as product class. For the required fields, it will contain a constructor. For optional fields, it will contain functions whose return type will be the product builder instance. For example, in this class, we have description, category, and base price as the optional parameters. And to set the value of these parameters during the object creation, the function we have defined is the return type is product builder and it takes description. The functions to set the value of this field will return the builder object, which can be used by the client to set the value of other field on the same object. Once the client defines all the values, at last they can call the build function, which will create the object of the class with specified values. As you can see on the right side, this is how the builder class will help in creating the object of the product class. It will first initialize the product with the required parameters, and then you can define the values of optional parameters, and finally you can call the build function whose return type is the product class. Coming on to prototype pattern, when you have an object of a class and you want to create a new object with slightly different value, then prototype pattern helps you do that efficiently. How? Let us look into that. This pattern implements a function clone derived from the interface clonable. The purpose of the clone function is to create a new object with the values from existing object and return the newly created instance of the class. The client can then modify the values as required. This helps eliminate the dependency on sources of other value and abstracts the complete cloning process as well. As you can see, from a existing object of the class, we'll just call clone and it will create a new object for us. And the client can set the different value to the parameters on the cloned object. The example we saw was cloning of primitive data types, which is also called shallow cloning. If a class contains complex data type, for example, category have fields ID and name, and category is part of the product class. When we'll make a clone of the object, it will not clone the category, rather it will use the same reference from original object. If we change the value of category in first object, it will also impact value in cloned object. This should not happen. To overcome this problem, we go with deep cloning. In deep cloning, we implement the clone function in our category class as well. And during the clone operation of the product class, we clone the category object and set the value in our cloned product. This way, any change that you will make in the source object will not impact the values in the cloned object, and vice versa is also true. Any change that you make in the cloned object will not impact the value in the source object, and this will solve our problem. Factory pattern. This is one of the widely used design pattern. This pattern is used to create different instances of the classes which are implementing the common interface. To understand the implementation of this pattern, we will take a validator interface. Define a function validate inside it. We will now implement two classes, name validator and price validator, implementing this interface. Now we will define our factory class, name validator factory, and implement a function get validator, whose return type will be validator instance. This will return the concrete validator classes based on the input parameter. The client can just use the validator factory to get the validator it wants by passing the parameter and call the validate function on it. This helped in decoupling the client from the actual validator classes, made our code extensible, centralization of all the validator classes and their logic. Say tomorrow, if we want to add a new validator type, category validator, we'll just implement a new category validator, update the validator factory function, get validator, and that's it, will be done. The last design pattern is abstract factory. I refer this pattern as factory of factories. I'll tell you why. It helps you create families of related or dependent objects without specifying their concrete classes. For example, let us define product interface and fulfillment interface. These are two different interfaces. Now we want to define two different types of products, physical product and digital product. The fulfillment for these products will be different. For physical product, we will be having shipping type of fulfillment, and for digital product we will want download type fulfillment. To manage a particular type of product, we will create their corresponding factory classes. For physical product, we will create physical product factory, and for digital, we will create digital product factory. Both these factory will implement a common product factory interface, and that's how you are combining multiple factories under a single product factory interface, and this is called the abstract factory pattern. In future, if we want to add a new type of product, we will just define their concrete classes and new product factory, and that's all. Now we will look at the code of the abstract factory. It is same as how we have defined in the UML diagram in the previous section. We will define the two interfaces, product and fulfillment. We will define their concrete classes for physical product, shipping fulfillment, digital product, download fulfillment. Then we'll define their product factory, physical product factory and digital product factory, and finally the interface of product factory. And that's how our client will be able to use our abstract factory to create any type of product they want. In this example, we have used digital product factory and it is creating a digital product. So that was all about creational design patterns. I hope you learned something new today. Please do subscribe to the channel for more upcoming videos. And the best way to gain expertise in design patterns is to practice. You can practice on your day-to-day basis. Either you are writing the code or you are reviewing the code. Just take a pause and think for 1 or 2 minutes which type of design pattern can be most suitable for your code. And generally when you are building a new service or working on a small component, these patterns are really helpful. Not just in terms of making your code extensible, but it also showcases your knowledge to other peers and to managers who will evaluate your performance annually, and this can actually be a good point to showcase. Thank you.